Hey there, Nectartacus here. In this video, we're going to go over how to randomize lines in a file, as well as pick a number of random lines in that file too. This could be useful for a couple of different use cases. Maybe you're running something like a contest where you have a list of emails in a file and you want to pick 3 random winners of choice. Another use case is maybe you have a whole bunch of different names in a file and you want to pair people up into groups of 2, maybe some type of matchmaking service here. So you can pick 2 random people, then another 2 and another 2 until you have no people left, or maybe 1 as a remainder, and then you can do whatever you need to do based on your use case. Again, that's only 2 basic use cases here, and we're going to be using the command line using both the sort tool as well as the shuf tool. I will say though, if you are using macOS, neither of these options are going to work out of the box. You will need the GNU version of sort as well as installing shuf on macOS. So one quick way to do that one is to brew install core utils. I'm not going to run it here because I'm not running macOS, but if you are running Mac and you want to follow along, then you can install core utils, and instead of running the sort command like sort, it's going to be gsort, like gsort, and then shuf is going to be gshuf instead. So yeah, if you want to follow along on macOS, then you may want to do that here. But yeah, before we get into the details here, I will mention that we can run the sequence command here with some type of number, and that is going to generate an ordered list of numbers here, which is going to be pretty handy for testing out both of these sort and shuf commands, because now we have some output here that we can actually shuffle. So, we can run sequence with 10, or we can run it with 3, whatever we want here. We get a sequence from 1 to whatever number that we pop in here. So yeah, let's just play around, and we'll start with using the sort command. So if you run sort just like this, we're not going to have any difference because the numbers are already sorted here, 1, 2, 3, 4, 5. But yeah, let's say that we want to do a random sort of this one. So we can just do random sort. Or the shorthand flag for this one is capital R. Both are going to work the same here, but you can see we are getting different outputs here, right? This is going to be randomly sorting this one. And there is another flag that we can add to this, which would be pretty interesting depending on your use cases. We can use unique here, and that's not going to make a difference in this case because, we just have 1, 2, 3, 4, 5. There's no duplicates here. But yeah, depending on your use case, maybe you do want the list to be unique because, maybe you are pairing a couple of people up, groups by names, and, only 2 humans could be present in one point of time at once. So you wouldn't want to have someone being in 2 different spots, or, depending on how you're running a contest, maybe quite a few different folks could be entered more than once. In that case, you wouldn't want uniqueness, but if you only want one person to be entered once, then yeah, sure, using unique would be nice if you had like a list of emails or something like that. So yeah, that's the basics of using the sort here. And right now, we're piping in the output of sequence to this one. But if you wanted to just read this from a file instead, like imagine we just had another file here called like whatever, right? Then we can actually feed that right to sort, and we can just be like whatever, and then we can do random sort, and that is going to do the same thing here, except now it's reading it from a file. And also sort has an output flag, and now we can do like whatever sorted. And then, well, actually this would be shuffled, not sorted. So let me just go with shuffle there. And then, yeah, we can just take a look at here and just, by the way, spoilers, we're going to be looking at some benchmarks soon. But yeah, we can just like see whatever, and then it's shuffled here. So whatever we got there is what we got here. So it is very easy to, output things to a file and read things from a file instead. And I will mention that we're going to be going over the shuf command right now in a second. It also has the same flag here for output as well. And like reading it from a file instead of sequence is going to be the same thing. Okay, so let's take a look here at shuf and do the same thing. So we can do seq5, whatever, or, sequence of 5 here, and we can just pipe that into shuf, and that's going to do the same thing. It's going to shuffle things. Interestingly, we got 1, 2, 3, 4. Actually, no, that's a 5 and a 4. It's a swapped. I thought we got maybe lucky on video and got them in order, but nope. But actually, there is a more interesting way to shuffle things without needing to get the sequence piped into it. For example, you can use the I flag here with shuf and do like 1 to 5 here, and that is going to do the same thing. This is actually quite a bit more efficient, which we're going to see in the benchmarks pretty soon. One nice thing here too is we can do like, 5 to 20 instead of 1 to 5 here, and then we can see we get all of our numbers here, starting at 5, which is over here, and then ending at 20, which is pretty nice. Okay, so now let's go over some benchmarks here. And, I put these into a file. I ran these ahead of time here because, some of these take like over a minute to run. I didn't want to cut the video, and surely we're not going to wait for a minute and a half here. So yeah, it's kind of interesting. Like, let's see how fast all of these solutions are. So I just ran some benchmarks starting with 100, then it's like 1,000, 10,000, 100,000, a million, and 10 million here just to see what happens here. So yeah, let's just start with the sort here. And again, I didn't use uniqueness here because shuffle isn't going to be unique. So I wanted to make sure that we're, playing a fair game here and doing the same amount amount of work in both of these here. But yeah, we can see here it's basically instant, 45 milliseconds. Let's call it half a second, 6.5 seconds, and a minute and a half to use sort here to sort a sequence of 10 million numbers here, and then just outputting that to a temp file here. And then if we use shuf, also with the pipe, with the sequence here being piped into shuf, we can see it's quite a bit faster, right? The last two here, 6.5 seconds, minute and 20, let's call it. This is 43 seconds for the top end, and then about half of that here for a million lines. So we're dealing with about twice as fast here to use using shuf here. And what's even nicer too is if we actually let shuffle deal with its own sequencing of numbers here, the same thing all the way from 100 to 10 million here, we actually see that it is 19 seconds total, which again is about twice as fast as just using sequence piped into shuf here. And again, like 1.7 seconds here for a million of them, which is pretty reasonable. Now, you might be thinking like, well, okay, so how long does it actually take to generate these sequences here versus actually just shuffling some output there? And yeah, I did that here. So, we can sequence 10 million here to a file that took on my machine about 2.2 seconds. And then to actually use shuffle on it, for this lines here with a new output file of like lines shuffled, that took about 37 seconds to do here, which is pretty nice, right? And if you go back to the numbers up here, this was like 42, let's call it almost 43. And then here is like 2.5. If you add this to like 2.5, it's like basically what it was. Of course, this isn't super scientific. I should mention too that all of these numbers were ran on my workstation, which is 10 years old. I built it up from parts. It's an i5 3.2 gigahertz machine with 16 gigs of memory and a first gen SSD. So we're talking like a decade old machine. I'm sure if you ran this on a more modern machine, these numbers are going to be a lot faster. But there is a takeaway here in that, if you're trying to shuffle, multiple million line file very frequently, then this is probably not going to be a good choice, because even though this is like reasonably fast, if you had to run this, 500 times a day or something like that, or it's really important that you get the result back a lot faster, then you may need to look into a different type of solution here to get those lines out in a more efficient way. That's not something we're going to be covering here. But yeah, I just wanted to throw that out there. If you're just like, doing this for a contest or pairing up like 5,000 people or something, it's going to be fast enough. If you're just running this every once in a while. So that covers just randomizing an entire file. But let's say that you have an entire file and now you just want to get, 3 lines out of that are random, or, 1 or however many you need. So we got a couple of different ways we can do that one as well. For example, if we go back to our basic example here using sorts, we can do just what we did before. And by the way, if you want to use a shorthand flags, that works completely fine as well. We can use -RU here, U for unique, and the -R is random sort here. But yeah, that's going to give us all 5, right? But we can just pipe that into head and get 3, or maybe we just want to get 1. So if you're using sort to do this, then yeah, you can just pipe it into head here, grab however many that you want here. We can just rerun this a couple times. We are getting a random result there. But now let's say that we want to do the same thing, but we are going to be using shuf. So if we can use shuf just like we did before here, in this case, I'll go to the 1 to 5, just peeling it back to what we did before. There's no reason to use sequence and pipe it into shuf. We already determined that this method is a little bit quicker here. But yeah, there's another flag we can actually use here to be the number that we want to actually get returned. Like how many of these 5 do we want back? We want to get 3, we want to get 1. We can just, do this as many times as we need here based on our sequence. Now, I just thought about this now, like, actually, what happens if you put in something like 10, which is, greater than the actual number that we get here? Are we going to get an error from shuf, or will it just like round it down to the max over here by default? And yeah, it actually looks like it's trying to be nice to us, and it will round things down, so you don't get an error. Although, in this case, it probably would be a little bit more better, more explicit to make sure these things actually make sense when you read them out here. Just going back to this benchmarks, probably if you're looking for a reasonable amount of speed, just for like some ad hoc ones, you might as well use shuf like this. So with that said, let us know in the comments below what type of use cases you might be solving by running these commands in the command line, or maybe putting them into a shell script. If you have any questions, let us know in the comments below. I'll do my best to answer all of them. If you liked the video, please give it a thumbs up because it really does help a lot. Thanks a lot for watching, and I will see you in the next video.